Okay, so let's talk about the administrative issues of this course. We're going to start by trying to explain why we're doing this course the way we are. I'm going to make an analogy to a car. When you drive a car, you don't need to know the actual underpinnings of how it works, right? As a driver of a car, basically you know about the car above the hood, like what is the application of the car, how you can drive it, how to use turning signals, what are the rules of the road, etc. So this type of big picture context of why moving around in the world is important is part of what we call the above the hood idea. And the same is for machine learning. So we want to understand how we can apply these concepts, what are the real world implications of this, but not necessarily in the above the hood part, like the mathematical underpinnings. So here we're emphasizing things like the big picture, as well as hands-on exercises that you're going to do through Coursemology, as well as a Google Colab, as well as connection to industry. We'll be featuring a couple segments where we have interviews with industry leaders as well as academics in our school. Okay, and most of this type of information is really meant for C-level executives as well as people who just need to know about the bigger context. But for our course also, we want to emphasize what we need to know below the hood. It means all of the mathematical underpinnings so that we can develop new algorithms. So this will include proofs about convergence of certain algorithms and how they relate to each other. And the math is really the most important part for mastery and grounding, because you will need these insights to develop better machine learning algorithms in the future. So that's a very important part, which a technician, let's say in an auto shop, would need to know how a particular engine component works. Similarly, for machine learning, we're going to give you the basic mechanics of how all of these parts work. And in future courses, then you can go further and try to learn more of the details about specific components. So there are some significant barriers to success in this course, and I want to give them to you up front so you have some good idea of the expectations that you should have going in. There's going to be some serious math. So for many of our competing students, you may not be as strong as some of our fellow students from math and science on the mathematical parts. So you will need to brush up, especially on your probability statistics and linear algebra components. And luckily for you, we have some TAs and some background information that you can do in weeks 2 and 3 to try to get you up to speed so that the rest of the course won't seem so difficult for you. For others, programming competence is difficult. So that will be another part that you'll need to make sure that you have a good handle on. And again, we have practice for that. We have our weekly collab notebooks that you're going to do also in Coursemology that will help you with that. So if you haven't learned any Python, this is a good time to practice that. Again, there'll be some exercises even in week 1 in the in-session class, which will help you with that. And again, just to reiterate, this is the new normal, right? We are flipping the classroom, so you will be seeing me mostly through these pre-recorded videos instead of live. So you'll have to get used to that. It allows you the capability to watch anywhere, anytime, but it also means that you have to work especially hard to engage your class instructors as well as your peers through your group project and your tutorials. So the basic 4 student learning outcomes that we have for you in this class are as follows. It's basically to be able to understand the basic concepts of machine learning, be able to apply the appropriate machine learning algorithm for a given problem, evaluate the performance of a machine learned solution. This is going to be very critical because many times we want to optimize the framework so that we can get better performance. We need to know what metrics to use and how to optimize the model so that it can achieve better performance. And finally, use a machine learning tool to carry out machine learning experiments. This is going to be embodied through your project. You're going to try to use different parameters, observe the results, as well as formulate why you should see those results as a hypothesis at the beginning. Then you're going to diagnose all of this and come up with justifications. This is an important part of the scientific process, which you need to practice throughout the life cycle in the project. Now, as I've already iterated before, we're going to be using Python and Google Colab quite extensively in this course. And that's a good thing because these are recent technologies that allow you to experiment in more or less a WYSIWYG fashion so that you can observe results as you're coding. In particular, we're going to be using the Python 3.6, not 0.7 option because that's what's supported for most of our work. And you can use this through Google Colab, but we also encourage you to try to install this type of technology on your own laptop or desktop. It's not too hard to do on most computer systems. Windows and Macs both have that, and Linux, this is a sure thing. Okay, but of course, you can just use the platforms that are already out there on the cloud. So Google has nicely created a Python version that you can get that runs pretty much all of the information that you'll need for the course. However, when you're executing a project, again, probably this particular platform of looking at Colab is not going to be sufficient. So please do invest early on in this course before week 4 or 5 to start to get some computational resources either in your home or through AWS, through Amazon Web Services, which are also have capabilities to utilize during this course. Now, I think most of us have experience with Python, but even if you don't worry. This is an extremely easy language to learn, and that's why it's the favorite choice for many first programming languages. And it actually integrates extremely well with machine learning because there have been a lot of toolkits that work with Python very well. One of the libraries is, that you'll use in Python a lot is called pandas, and that's why you can see here that we have panda mascots for our course as also featured on our website. So I hope you enjoyed that little bit of trivia for our course.